Figure 18 shows identical filament lamps connected together to a 12-volt power supply. Calculate the potential difference across each lamp. So remember, in a series circuit, and you can see these are connected in series in one loop, all the voltage is shared, and that's what it's testing you on. So all the voltage is shared here. So you're just dividing 12 volts by the number of components that are sharing it. So 1, 2, 3, 4, 5, 6, 7, 8. And so you do 12 divided by 8, which is 1.5 volts. Really quite easy. The power output of each lamp is 0.75 watts. Calculate the resistance of each lamp. Now this is a 4-mark question, so how do we work this out? Well, firstly, we need to work out resistance from power output, and you can't really link those two directly, so how do you do this? Well, firstly, you need to use Ohm's law, because that makes sense of resistance, voltage, and current. Now with this, you have voltage, 1.5 volts, you have to get it from the previous question. You haven't got current and you haven't got resistance. So we've reached a dead end here because you can only solve this if you have 2 of the 3 factors. So now let's look at a different equation which involves power. Well, power is current times voltage. Now we do know power and we do know voltage. So we can rearrange this equation. Power divided by voltage, you can use the 632 method if you want. Power divided by voltage equals current. So 0.75 divided by 1.5 is 0.5 amps. And now we have this value here and we can work out the resistance. So 1.5 divided by 0.5, remember voltage here and current here, is 3 ohms. So this is a 4-mark question because we're using 2 separate formulae. We are rearranging both of those formulae, so you get marked for that. And we are drawing across values from different questions as well and substituting them in here. Finally, explain with the aid of a circuit diagram the method a student could use to investigate how the resistance of a single lamp changes with the potential difference across the lamp. So a method we have to explain, and you can use a circuit diagram, so that's nice. A method a student could use to investigate how resistance of a single lamp changes with the potential difference across it. So this is our setup. We have an ammeter, a bulb with a voltmeter in parallel. Remember, ammeters must be in series because they allow current through, so they can measure the rate at which that current moves through. You get a reading of current, the rate at which the electrons move through. And voltmeters connected in parallel because it measures the difference in energy between 2 points. So the energy the electrons have at this point before the component, the energy they have after the component, and they work out the difference, which is why we call voltage potential difference, the difference between the energy at 2 points. And that difference will be the same as the energy transferred out by this bulb. It makes sense. All right, so that's our circuit setup. So remember, to work out resistance, V equals IR, voltage equals current times resistance. So resistance equals voltage divided by current. So what we'd have to do is change the voltage. So we could change the power supply. We can up the voltage there, and we'd have to take the readings of voltage and current across the bulb, voltage across the bulb and current running through it, and we'd have to step them up incrementally and work out the resistance each time. So measure current with an ammeter. That's one important point. Measure potential difference with a voltmeter. Vary the potential difference using the power supply. Calculate resistance using R equals V divided by I, voltage divided by current. Repeat and compare results, and that's it. It's one of the easiest 6-mark questions if you just follow it through. The diagram helps you a lot.